On now. Hold on there. Okay. We just did falling asleep with using caffeine on students' rating of ideal sleep. This is exciting. I haven't done this one. Now, why am I doing this, first of all? Because it's fun? Well, yes. That's not important. Do you need to do this for your final project? Yeah, so I want to go through and I'm going to show you how to do this like 7 different times because you're going to have to do this with your final project. And you're going to need to get your questions from my Introduction to Psych students soon. I haven't seen my TA, so I might be entering the grades. Okay, so now, what this shows is that the caffeine is affected what you think is ideal sleep. I need to make that graph. That's a very exciting graph because I love caffeine. So, I'm going to make a, what do I make simple or clustered right now? Yes. Which one? Actually, Helen's right. Why do I make a clustered bar graph? There's 2 variables that have a significant interaction. There's 2 variables that have a significant interaction. Okay? So let me hit reset to start again. We're measuring ideal sleep at this point. And then what are the 2 variables? Caffeine and TV. So now, there's no differences. Ooh, look at that. There's no differences in ideal sleep between falling asleep with the TV on, unless you look at caffeine. Let me just make this line graph so you can see this interaction better. Yeah, I see crossing lines. Okay, so if you use caffeine, the blue line. I'm talking if you use caffeine. No. Oh, sorry, if you use caffeine, the green line. You know this better than I do. Okay, so if you're using caffeine, does falling asleep with the TV affect your ideal sleep? Wait a minute. You choose your ideal sleep. So you choose your ideal sleep. So if you like to watch TV and you like to drink caffeine, you have a higher amount of ideal sleep than someone who doesn't fall asleep watching the TV, who uses caffeine but doesn't watch TV. Oh, geez, this kind of hurts. Look at the people who don't use caffeine, who don't fall asleep watching TV. What do they want? More sleep. People who don't fall asleep watching TV but also drink caffeine want less sleep. People that drink coffee, that watch TV, require more sleep. Now, this is important. Can you actually draw a conclusion from this? Again, watching you make decisions makes it really good for recording on this. But but again, this is a really important interaction. So all you have to explain it, what do you have to do? I mean, this error bar graph explains it actually pretty well. Are these 2 groups significantly different? You don't know because you have to prove it. Okay, so working the visual effects. So now, so where we're going to go is we're going to select cases, and if caffeine equals 0, continue. Okay, so I've just selected the no caffeine people. Now we're going to look at TV. Are they different? So all we have to do is do an analyze, compare means, independent sample t-test, get rid of that, put that in there. We're done to go. Click. Are those 2 groups different? No, not statistically different. If you get a 0.08, is that close to 0.05? Yeah. So you might say, trend. But again, that's not where the differences are. The differences aren't for people who don't use caffeine. The differences seem to show up for people who use caffeine. Oops. Yeah, thank you. Quit knowing this better than I do. Select cases if caffeine equals 1. So now we look at the caffeine drinkers and analyze, compare means, independent sample t-tests, okay. And what do you see? The groups are significantly different. The difference, the reason why there's significant interaction, is the difference isn't the same direction. The difference is not the same direction. For example, when you fall asleep watching TV, these people said yes, but that value is lower than people who said no. When they use caffeine, the opposite is true. And the more different each group is in the opposite direction, the greater the probability of a statistically significant interaction. Now, 0.03 is not, nearly as robust as 0.001, but at the same time, is it still meaningful? Does it mean you should look further at the data? Yes. So now, do you think you're going to find lots of exciting, fun things on your final project like this? You're going to shaking your head no, it doesn't work on a audio recording. But you're not going to find great. This is really exciting. It's fun to find this effect. It'd be really interesting, and I got to quit doing analysis on this because every semester I find out new things to look at. To actually look at sleep debt score, and I'm going to throw stress level on top of all three of these things. There's not enough people. Oh, cases are selected. Come on, man. Analyze generally your model, univariate. Okay. You ready for this? TV, caffeine, and stress level all affect your sleep debt. They all interact to form sleep debt. Three-way interaction. You have to wait till graduate school to do the math on that. Does caffeine and stress interact? 0.052. Is it greater or less than 0.05? Greater. Dope. TV and stress. We already saw that one. TV and caffeine work. I want to go see this three-way interaction. But you have to wait till graduate school in order to figure that one out.